Good morning, students. Today's topic is how there is generation of nerve impulse as well as conduction of nerve impulse takes place. To understand that, we must know that in the neuron there are three channels which are located. Channel means a proteinaceous structure through which ions can move. First type of channel is leaky channel. It is always open. It leaks either sodium or potassium. There are two kinds of, not either, there are two kinds of leaky channels, sodium leaky channel and potassium leaky channel. You have to remember that in the neuron membrane, there are less number of sodium leaky channels compared to potassium leaky channels, which are more in number. Second type of channel is voltage gated channel. As the name indicates, gated, it is closed channel, open only when particular voltage is applied. What are the types of voltage gated channel? Sodium voltage gated channel, potassium voltage gated channel, and the calcium voltage gated channel. Sodium voltage gated channel can operate at minus 60 millivolt, potassium plus 30 millivolt, calcium plus 30 millivolt. Among three, you have to remember sodium potassium channel, it is always the first one, it is fast to open. Third channel is mechanical gated channel. It is also closed. When a mechanical pressure is applied, it will open. Example for mechanical gated channel is sodium mechanical gated channel, which will allow movement of sodium when a particular mechanical pressure is applied. We'll be learning generation of nerve impulse under three segments: resting membrane potential, action potential, and propagation of action potential. When a neuron is rest, to maintain that resting state, what are the things that happens? Let us understand. When neuron is rest, which means it is not conducting any impulse, inside there will be negative charge, outside the neuron there will be positive charge. Why there is negative charge inside? It is in terms of positively charged ions. Let us say outside membrane there are 100 positively charged ion, inside only 30 positively charged ion. Similar condition exists here. Outside positive charges are more, inside positive charges are less. Hence I can say that now inside minus 70 charges are less compared to outside. Same thing. Outside there are more concentration of sodium ions, inside there are more concentration of potassium ion, but compared to sodium, potassium is less inside. Hence outside is plus, inside is minus. Also, the inside there are negatively charged ion, there are negatively charged protein that is responsible for negative charge, but it is mainly because of change in positive charges which is responsible for all this polarity. Apart from that, who will maintain that potassium and sodium concentration? It is due to two reasons. First reason is sodium potassium pump, which is also known as potentiogenic pump. Sodium potassium pump, it will operate at minus 70 millivolt. It will bring 2 potassium inside and 3 sodium outside, which means sodium, if you consider this as a sodium potassium pump, it will pick up 3 sodium from outside, bring it inside, and from inside with the same hand it will pick up 2 potassium, throws it to the outside. So say that is the function of sodium potassium pump. Apart from that, second thing which maintains this concentration gradient is leaky channels. As I mentioned, sodium leaky channels very less in number. It will allow the leakage of sodium from higher concentration, that is outside to inside. There are many potassium leaky channels. It will allow the leakage of potassium from inside to outside. Again, positive charge from inside is going out, hence it is minus. So one more important statement which NCERT gives is membrane at rest is more permeable to potassium than the sodium. Why? Membrane at rest will be having more potassium leaky channels compared to sodium leaky channels. Hence, membrane at rest is more permeable to potassium compared to sodium. When you measure the voltage which is generated because of sodium potassium pump and leaky channels, you will find that voltage is minus 70 millivolt, and that is nothing but resting membrane potential. At this condition, since the charges are opposite of outside and inside, the membrane is said to be in a polarized state. Therefore, when the neuron is not conducting any impulse, it is said to be in a polarized state or a resting, that is known as resting membrane potential. It is minus 70 millivolt. Action potential. Action potential begins with depolarization. You know, in the graph we have marked minus 70 millivolt is the resting membrane potential. Now consider you have applied any mechanical pressure. Look at here, I have shown one pen touching the neuronal membrane. When mechanical pressure is applied, mechanical gated channel like sodium gated channels will open up. There will be rapid influx of sodium into the neuron. When there is more entry of positively charged ion into the neuron, minus negativity inside the axoplasm becomes, it goes towards more positivity, minus 70 will become minus 65, again sodium will enter through mechanical gated channel, it will reach minus 60 millivolt, that is known as threshold potential. When minus 60 millivolt threshold potential is reached, there is voltage gated channel. At that voltage of minus 60 millivolt, sodium voltage gated channel will open. Again there is rapid influx of sodium into the neuron. Positivity rises within the cell. The positivity will reach 0, plus 10, plus 20, ultimately plus 30 millivoltage is reached. Third step I have shown in the form of step. First, mechanical gated channel open. At threshold potential, voltage gated sodium channels will open. Plus 30 millivolt action potential is reached. As a result, now inside plus 30 millivolt, outside minus, because from outside sodium positively charged ions are decreasing now, compared to inside. Outside has got less positive charge, that's why outside is negative. So in this condition, membrane is said to be depolarized, inside positive, outside negative. When the plus 30 millivolt is reached, what are the changes that occurred? Let us understand. First, when threshold potential of minus 60 millivolt is reached, sodium potassium pump has stopped, because sodium potassium pump can work only at minus 70 millivolt. Second thing is, when the plus 30 millivolt is reached, now one more channel opens, that is potassium voltage gated channel. Potassium voltage gated channel, look at here, I have shown potassium is more inside, it will start moving potassium ions from inside to the outside, since in interior of the axon it is losing positively charged ion, hence positivity will keeps on decreasing. First, because of movement of potassium, it will come to plus 20, plus 10, 0, minus 10, minus 20, minus 30, minus 70. Again, resting membrane potential is reached because of sodium voltage gated channel. Hence, inside axoplasm now minus is regained, outside again it will become plus. So polarization is regained, hence it is known as repolarization. You have to remember, depolarization is because of sodium voltage gated channel, repolarization is because of potassium voltage gated channel. When plus 70 millivolt is reached, sodium potassium pump starts operating again. What has happened now? Sodium has entered inside, potassium has gone outside. Now that concentration gradient has to be brought back to the original state. So sodium potassium pump, it will start throwing 3 sodium outside, brings 2 potassium inside, hence it will maintain the resting membrane potential. So this is about depolarization, repolarization and resting membrane potential. Now we have to understand how depolarization and repolarization leads to propagation of action potential. Let us take a neuron. I have divided the neuron into three segments, A, B and C segment. Say that in the A segment, now depolarization has occurred, which means rapid influx of sodium has taken place. That will stimulate the next part of neuron also to be depolarized. Hence, when A is depolarized, next B will get depolarized. When B get depolarized, A will again repolarized, which means when segment A is depolarized, B will also be stimulated to depolarized. When when B gets depolarized, A will be repolarized. That is the meaning. Or let me give an idea. Say that there are segments A, B, and C. Now in the A, because of rapid influx, there is depolarization, hence because of more positive charge, it is plus. Next segment, which was in resting state, because of the entry of sodium, sodium will stimulate the next section to become depolarized. When next section becomes depolarized, in the first A segment, plus 30 millivolt is reached, potassium leaky channels will open, potassium is lost to the outside, again resting membrane potential is regained. So this is how a wave of depolarization keeps on moving from in the neuron from segment to segment, finally reaches the nerve ending. In the nerve ending, when the plus 30 millivolt action potential reaches, it will open up the third channel, voltage gated channel, that is calcium voltage gated channel. Because of that, calcium will enter into the axonal membrane, axon tip. It will stimulate the synaptic vesicle to fuse with the axon end. When synaptic vessel fuses, there will be release of neurotransmitter. Released neurotransmitter will stimulate the next neuron. So this is how action potential generated in the neuron, finally it will end up in releasing neurotransmitters which will stimulate the next neuron. So this is about generation and conduction of nerve impulse. Thank you. I hope you understood. If you have any doubt, you can mail me. Thank you.